Okay, so rotational symmetry is if you can turn it at all and it comes out the same picture. It doesn't specifically have to be a half turn. It could be a fourth of a turn. Okay, this point symmetry means if you hold it down in the middle and you mark a point on this top right, will it end down here at the bottom left with a half turn? Because we have to do a half circle for point symmetry. So if I hold it in the center and spin it around half a circle, there's half a circle, and hey, the point landed where it was supposed to be. So yes, we have point symmetry too. So point symmetry has to turn at a half circle. Rotational symmetry, you can turn any amount, and if you get the same picture back, it's rotational symmetry. Okay, number 10, it says find the complement. Complement means add up to 90. Or it means to find the other angle, we can say 90 minus 6, 84. Huzzah! Okay, the next sucker says supplement. Supplement means it adds to 180. Or you can subtract the angle they give you, 140, from 180 to get the supplemental angle, or 40. Okay, let's keep going. Number 12, it says find the complement of an angle measuring x. Wait, what does it say? The complement of an angle measuring x is 5x. Solve for x. Okay, so x and 5x add to 90 because of that word complement. So let's do it. We're going to have x plus 5x, and it equals up to 90. And then it says solve for x. So let's add 1x plus 5x is 6x. Divide by 6. And x equals 15. Hey, bam. All right, let's go to number 13. It says the ratio measures of two angles that are supplementary is 6 and 3. What are the measures of the two angles? Okay, that's kind of like saying this x and 5x. We're going to say this 6 and 3, we're going to change it. So it's saying out of supplementary angles add up to 180. Yeah. So it's saying one angle plus another angle should be 180. And the ratio of those angles is 6 to 3. Okay. So let's think about this. I have the number 6. And I have the number 3. Let's maybe pretend they're x's. 6 times something and 3 times something will give us 180 when we add it up. So let's figure out what that x is, kind of like we just did the last problem. So you get 9x equals 180, divide by 9, x equals 20. Okay, but that's not one of the answer choices. That's because we had 6 and 3. Where the scale factor is 20. Or, to get our new angles, we're going to take this 6x and say 6 times 20, that's 120. Then we're going to take this 3x and we're going to say 3 times this 20, because we just figured out what x was, is 60. So our two angles are 120 and 60. So again, to repeat that, I would probably just throw some X's on those, treat it like the last problem, and then don't forget to plug in that X at the very end to get that 120 and 60. Okay, next sucker, it says in a right triangle. The second, okay, right triangle. That means 90 degrees is in the right angle. It says the second angle is 50. What's the third? Well, triangles add up to 180 degrees. So 50 plus that 90 angle plus something equals 180. And we have to figure out what that is. So I think 50 plus 190, that's like 140. Okay, and then 140 plus what gives you 180? Well, 40. Yeah, 140 plus 40 gives you 180. So the answer is D. Okay, let's look at number 15. It says in the figure to the right, line DH is parallel to IM, line BO is perpendicular. That means 90 degrees, wherever it's talking about. BO and DH. So these are right angles, okay? And it says IJN is 60. IJN is 60 degrees. What is the measure of JEF? Okay, well, first, we can't quite get to JEF yet. First, we have to figure out what this angle beside the 60 is. Well, I know that 180 degrees is a line. So this 60 plus this angle beside it should be 180. So this 60 plus something should be 180. Well, that something is definitely 120. Okay, then there's this F property that says this angle on the inside is equal to the top angle. I think it's called corresponding interior angles, but those two angles are equal. So you can kind of see an F. You see the F? Yeah. So these two angles are equal. So this 120 that we just found is that orange JEF that we needed. Done. Woohoo. Okay, let's look at 16. Okay, we have to talk about the names. Okay. Prism looks like two triangles that are connected, as in triangle, triangle, connected. Yeah, okay. Anyway, this is a triangular prism. That's not what we have, okay? Right circular cone. We know what a cone is. It's an ice cream cone. That's probably it. Cylinder. Cylinder means there's two shapes. There's two circles that are connected. Okay, well, that's not our picture. Pyramid comes up to a point. Like, let's say I have a square. The pyramid comes up to a point. Okay, so ours comes up to a point, so it could be a pyramid, but When pyramids have circles as the bases, it's called a cone. So this is B, the cone. Okay? So the thing to remember here is that prisms have two of the same shapes connecting each other, and cylinders have two of the same shapes connecting each other. Okay? This says name the solid. Okay, well, a cone, we know what that looks like, an ice cream cone. This is not it. Cylinder, we know what that looks like. It's two circles that are connected, like a cigarette. Okay, yeah, that's not our picture. Trapezoidal prism and pyramid. The difference between those is that trapezoidal pyramid connects two trapezoids. As in, here's one trapezoid, here's another trapezoid, and if I connected it, it would look like a prism. Yeah, kind of like a water trough where your horses drink water. So that's a prism when you have two of the same shapes that are connected. Well, that's not what we have. Pyramids come up to a point, and that's what this one does. So, hey, D. Okay, next sucker. It says, give the name of the solid. Well, let's remember, cones have a circle, so that ain't it. Cylinders, triangular cylinder, what the, that's not even a, what? Yeah, that's not even a, no. Okay, triangular pyramid means we have a base of a triangle and it comes up to a point. So triangle and then comes up to a point. That's a pyramid. That's not what we have. We have two triangles connecting each other. That means prism. Okay, keep going. 19. List the edges. The edges are AB, AE, AF, all the way back down. Okay, and then it keeps going. ED, B, BC, D. Then I think the only two I haven't labeled is CF and FD. So, edges are the point to point, letter to letter. That's what an edge is. Okay? Vertices is just one special point. Okay? It says list the vertices of the figure. So, if we look at this top shape of a triangle, the vertexes are the corners. Same thing for that bottom triangle. The vertexes are the corners. Yeah. So those corners are A, B, E, C, F, D. All right, let's keep going. On this next one, 21, I'm going to omit it, which means you'll probably see it on the test, but it'll say something like your instructor has given you credit. And I'm going to omit it just because there's so many things to type in. I'm afraid we'll get something wrong. All right, let's look at the next sucker. Number 22. It says a truss used in house construction to strengthen roofs is shown below. Name two congruent triangles and tell why they are congruent. Okay. So, one reason that these two triangles are congruent is because they have a same side. Okay? Another reason why these two triangles are congruent is because they have the same angle. Okay? But then let's think about this. If I put a gap in between these two triangles, there's another side that's the same. It's that side right down the middle. And those are the same lengths because those two triangles are smashed up on each other. So we have one same side, two same side, and one same angle. So if we're looking for a reason, we want something that says a side, and an angle. So SSS is out. And then let's think about whether that A is in between the sides. So if I take one of these triangles, we said 20 was here, 60 was here, and then we said they share the same up and down altitude length. Okay, so let's label this to figure out what it is. This is a SAS, where the angle is in between these two sides. So SAS. Okay, and then now we have to label the triangles. Well, when I took them apart separately, I see triangle ABD. Okay, now we got to read this other triangle the same way. As in, when I said ABD, I said that angle that was on the very outside first. So this new triangle is going to be angle on the very outside, left and right, or C. Then I said for triangle ABD, we went to the top angle. Well, what's the top angle of this triangle on the right? It's B. Then for ABD, we went to the bottom angle, D. Well, what's the bottom angle of this triangle on the right? D. So we got ABD and CBD are congruent. Alright, let's keep going. Next sucker. Kind of the same-ish thing. It says, tell whether these triangles are congruent. And if they're not, tell that too. Okay, so I got these two triangles, and I see that they have the same right angle, as in they're worth the same amount, and then these E and B are the same angle. But the question is, what else is the same? Okay, well, if they shared the same side, like this last picture with the triangles butted up to each other, if they shared the same side, then we could say they're congruent. But they don't share any of the same sides. So, part A says the triangles are congruent by SAS. That means two of the sides are the same. But we didn't tell you that. Part B says SSS, meaning all three of the sides are the same. But we didn't even tell you any of them. Part C says ASA. It's got two angles, but we don't share a same side, so it's out. So it must be D. Okay, let's look at 24. Same thing. It looks like they have the outside angles the same. Right? Then it looks like this little right angle, those are the same, of 90 degrees. The question is there a shared side? And the answer is yes, because they're butted up next to each other. So that means both of their heights are the same. Okay, so let's see here. If I were to pull out one of these triangles, they gave us that angle on the bottom left. They gave us the right angle. So that's angle and angle. And then the side that they gave us that's shared, that's S. So let's see here. We need something that says AAS or SAA. Either way, we need two angles. Well, part A says it's not correct, but it is because we have two angles and a side. Part B says SSS. That's not what we have. Part C says two sides, but they're not the same. Part D says AA. That's us. AAS. Yay. Okay, let's look at 25. I'm going to omit 25 just because there's so many things that you have to find. I'm afraid of us getting one of them wrong. All right, let's go to 20. Actually, I think I have a video for this from now on. So from 26 to the end, there should be a video. Yay!